Alright, hi students. Welcome back to the second part of the video on nutrition in humans. So in the previous chapter, right, if you recall what we actually mentioned about, we actually talk about the processes involved in nutrition. We talk about what are some of the different organs that's related to the digestive system. Mainly we spoke about this thing called the alimentary canal, as well as the set of associated organs. And in the end, we ended off with this process called peristalsis. Okay, so that was the first part as an intro to nutrition. Now for today's lesson, right, itself, we're actually going to focus on what exactly does it mean for digestion to take place. But before we start, let's do a bit of a recap. Recap on what are the parts of the alimentary canal and what are the parts of the group that we call the associated organs. You can find this page on towards the end of your notes. It's on practice 1 if I'm not wrong. Okay, so can you take some time now? You should pause the video right now to at least list down as many as you can recall without referring to the notes. Right? So pause the video now and you can come back to the video once you are done with it. Because right now we are actually going to review what's the answers. The answers of the different organs are as follow. Okay, just want to point out some things that we mentioned in the other lesson. Okay, we spoke a bit about the esophagus, right? This is the one that has the where we first learned about the two different layers of muscles, the longitudinal muscles as well as the circular muscles. Okay, we also ended off by talking a bit about the gallbladder, liver, pancreas, etc. So just another recap, what are the three main nutrients that we know in our syllabus? Okay, I think this is not new to you guys. It's carbohydrates, proteins, and fats. Okay, but how are these larger molecules broken down into smaller molecules? In the previous chapter, we learned about this thing called the enzymes, right? The biological catalysts. Now they play a lot of functions. Some of them can do formation of bigger substances, which is what I call the anabolic reactions. Some of them can actually break down big substances into smaller molecules, and that's what I call catabolic reaction. Now, starch can be broken down by a certain enzyme, protein can be broken down by a certain enzyme, fats can be broken down by certain enzymes, so on and so forth. So maybe at this point in time, it's good to recap on what are some of these enzymes that you have learned in the first chapter. They are actually amylase, protease, lipase, maltase for maltose. If you recall, we mentioned a lot about the spelling of the enzymes. Okay, this is a typo over here. Sucrose is actually broken down by sucrase. Okay, but more importantly is to understand that actually all these processes are actually what I call digestion, because it involves a large molecule of nutrients being broken down into smaller molecules. This particular lesson, we are going to learn about how digestion actually happens at the different organs, okay, and what the enzymes involve. Now, to set the context, digestion actually refers to a process whereby larger molecules are broken down into smaller and simpler ones. The purpose of this thing is to allow the smaller molecules to actually diffuse into the partially permeable membrane of the cell and for it to be absorbed inside. Now, if you think about it for a second, over here I have a nutrient, I have a cell. There's a lot of pores because the cell membrane is partially permeable. Okay, this is actually a fat molecule. How do I know this is the fat molecule? I can see the glycerol over here, and I can see the 3 fatty acids that's attached to it. On a normal basis, the fat molecule is unable to enter through the plasma membrane because it's too big, right? So this doesn't happen. But with the help of digestion, what is happening is that we actually break up the fat molecule into smaller ones. This is what I call the glycerol, and these are my fatty acids. Okay, and since they are in the smaller structures now they are actually able to diffuse into the entire molecule. Diffuse into the cell by passing through the partially permeable membrane, and that's the idea of having digestion in the first place, because that's what we want. We want the smaller molecules to become small enough so that they can diffuse through the partially permeable membrane. So there's actually two kinds of digestion. The first kind is what I call physical digestion, whereby you mechanically break down food into smaller substances. The second one is what I call chemical digestion. Okay? Second one is what I call chemical digestion, whereby you break down larger molecules into smaller, soluble molecules that can be absorbed easily into the cell membrane. Just some example, physical digestion can include chewing or even the process of peristalsis, which you learned previously. Chemical digestion is where it becomes a bit more interesting because it tends to involve enzymes. Okay? Enzymes will play a very big role in chemical digestion.
And with her new teeth, she can take on more solid foods. Digestion starts in the mouth. Teeth grind up the food. Then, special glands under the tongue pump out saliva. to help break down and lubricate the food on its 12-hour, 13-foot journey through the gut. It'll pass from the stomach into the coils of the small intestine before finally passing into the large intestine. Waves of contracting muscle keep the food moving, a process called peristalsis. These contractions are so powerful, we can even eat upside down. For the first time, a new camera shows a high-definition view of how food travels through our bodies and into our stomachs. Food enters the stomach through a hole at the top. The stomach is a bag of muscle that churns, squashes, and squeezes food into liquid. About an hour later, the stomach squeezes the broken down food out through a tiny hole called the pyloric sphincter. The food enters the small intestine, an 11-foot coil of tube where we absorb most of the nutrients. The interior wall of the small intestine is lined with millions of microscopic projections called villi. These increase the surface area of the gut, making it easier to absorb nutrients. First, the pancreas pumps out a juice that neutralizes stomach acid. Then bile from the liver breaks down the fats into tiny droplets. After an hour and a half, the small intestine has absorbed most of the nutrients from the food. It's time for what remains to move on. It enters the large intestine through this, the ileocecal sphincter, a valve that keeps our food from going back where it came from. What's left is a mix of waste food and dead cells from the walls of the gut. The large intestine's main job is to extract water from it. Finally, after about 12 hours, we expel what's left of our first meal.
Alright, so as you saw in this video actually does quite a good explanation of how food actually processed through the entire digestive system and which are the different processes that take place at each of the location. Okay, so now let's put it into context by doing a simple activity right now. Okay, I believe that at home now you should have some biscuits with you. So let's think about what exactly happens to a biscuit after ingestion. That means you take it in. So let's imagine that today you are a biscuit. Okay, once they're being consumed in, what will happen is that you will enter the entire digestive system. Once you go into the mouth, you pass through the esophagus. Inside the stomach, there will be this churning process before you pass through the small intestine and the large intestines. Okay, eventually, you will be exiting the entire digestive system as feces. Alright, so that is what the normal food will experience as it goes through the entire system. So let's do this and try this out in wherever you are. Just take out a piece of biscuit. Okay, as much as possible, choose a plain biscuit, not something that's Oreo based or chocolate based or strawberry based, so that as much as possible make it something that has no taste at all. Okay. When you place it into your mouth, this is what I want you to do. I don't want you to chew the biscuit. I want you to wait until the biscuit is moist enough for you to swallow it. eventually when it's soft enough, right, you can just swallow it in. And if you're doing it right, at the same time, record the time that's taken before you taste the first bit of sweetness. Now, why do I say that? Because at the start, the biscuit won't have any taste. But once you put it in your mouth long enough, you realize that a certain sweetness will start to emerge out from the food. And of course, a lot of food will stay inside until it's soft enough to be swallowed. And just take note of how much time it took. But remember, all these things must happen without chewing at all. So just let the biscuit slowly get moist enough and allow you to swallow it in. So what exactly happened was, when you taste the sweetness over here, right, actually it represents that something must have happened to the biscuit, because initially the biscuit wasn't sweet, but somehow there was a process that allows it to become sweet. That means it's likely that digestion actually happened here. Why? Because in your mouth, the salivary glands actually releases what we call saliva, and saliva contains two important chemicals. One is called what I call mucin. Mucin is the one that helps to soften the food, makes the food very soft so that it can be swallowed down. The other one that I'm more interested in is the salivary amylase. Now, salivary amylase is an enzyme. It will digest the substrate called starch to form what I call the product, which is the maltose. Now, in this process, what happens is that starch will be digested by salivary amylase to form maltose. Take a note of this equation and copy it down into your notes in the blank space below, because this is very crucial. It shows you that in the mouth, starch actually goes through a conversion, or rather digestion, to form maltose. And we learned in the earlier chapter that maltose is a form of reducing sugar. And since sugar are supposed to taste sweet, that is the reason why a sweetness actually came out from something that has no taste at all. You can actually do this with your bread at home, the plain bread. Okay, because plain bread by default shouldn't have that much of a sweetness taste, but once you leave it in your mouth for long enough, the starch will be digested, the maltose will be formed, and you'll be able to taste the sweetness. Yeah, in the mouth, the teeth actually plays a very important role because it breaks up the larger pieces of food into smaller ones, right? And by doing so, it allows the entire subsequent digestion by amylase to be a lot faster. At the same time, you realize that the tongue can actually roll the food into smaller structures, which are called bolus. Okay, so that is how the teeth and the tongue actually plays a part. And this is actually what I call mechanical digestion. So if you recall that at the start I mentioned about the two kinds of digestion, this is actually falling under what I call physical digestion, because it involves the breaking down of larger substance into smaller ones, but it's not a chemical process, it's just breaking it into smaller pieces. Now, once the bolus is being swallowed down, what's going to happen is that you will pass into the esophagus before it moves on to the stomach. And that is with the help of what we learned in the previous video, peristalsis, as well as gravity. Now, just to recap a bit about peristalsis, see how much you can remember. Okay, what exactly is the definition of peristalsis? What exactly are involved in peristalsis? Now, peristalsis is the rhythmic wave-like muscular contractions in the wall of the alimentary canal. That's what we learned from the other video. So what exactly happened during peristalsis? We recall that something must happen over here, which is what I call constriction of the wall. At the same time, something must happen over here, which is what I call dilation of the wall. Okay, and this is the part whereby we learn about the mnemonics. Do cats really like cars? Okay, so I'm not going to go in depth into what it is, but you can refer to your notes. Okay, so in the stomach, after it passes through the esophagus, right, the food, once it enters the stomach, it actually stimulates the gastric glands to release gastric juice. Now, gastric juice contains two very important chemicals. One is hydrochloric acid, one is pepsin. Now, pepsin is actually a type of protease. Okay, it's a type of protease that digests proteins, but please take note of this name because it's a unique name, because this is only found in stomach. Okay, so you will learn that some enzymes have a special name because of how unique they are, but pepsin is just another kind of protease. That means they're supposed to act on proteins. In the stomach, the hydrochloric acid is there to do a few functions. Number one, is there to denature salivary amylase. Now, if you recall, this came from the mouth, because when you swallow in the food, right, the salivary amylase will also be swallowed down in. So, with the help of hydrochloric acid, what happens is that initially the salivary amylase should function as what you see in this video. But once there's a change in pH, it actually becomes denatured. Why? Because hydrochloric acid is actually an acidic substance, which means that it's going to change the pH. Then it's going to affect the salivary amylase, because salivary amylase, which came from the mouth, has an optimum pH of about 7. Okay, because in the mouth it's a neutral condition. So that's how your salivary amylase behave like. The second function of your hydrochloric acid is that it actually allows an optimum acidic pH for the enzyme called pepsin. Right? And last but not least, it actually helps to kill off harmful microorganisms that's in the food. So all the bacteria, all the germs, right? The acid can help to kill off some of them. So this enzyme pepsin actually functions best under acidic pH. So if you think about it for a second, if there was to be a graph on the rate of this enzyme pepsin, how well it works, and if you change in the pH, can you recall how should the graph look like? Okay, it's not hard to imagine that if pH is 7 of neutral here, and this enzyme operates best at acidic condition, most likely its pH graph will look something like this, because its optimum pH is likely to be around maybe 3 or so. Okay, so that's something that you can use to deduce. So in the stomach, what happens is that the pepsin actually allows the digestion of proteins to form polypeptides. So these are my protein, okay? This is my pepsin. Okay, this angry looking structure here. It's like an enzyme. So you break it apart into smaller structures, which is what I call the polypeptides. Okay, if you recall, polypeptides are just chains of amino acids. They are not amino acids. Okay, they're not that small, but they are chains of amino acids. So like what I mentioned just now, you should be able to deduce what should be the pH effect on the rate of enzyme activity in the stomach. In the stomach, something else also happens, which is the churning process. Churning process is actually due to peristalsis. So if you know that inside your stomach, right, eventually sometimes if you don't eat, right, you feel this growling sensation. Because at all times the stomach is actually having peristalsis, trying to move food. Okay, so if there's food there, it helps to churn the food, something like a washing machine, okay, moving around. And eventually this entire motion will actually break into smaller ones also. And this is also what I call a form of physical digestion. Okay, because it's mechanical in nature. And the partially digested food is what I known as chyme. Then you will pass on to the small intestine when the muscle actually relaxes. Now, just a fun fact, whenever you're hungry, right, you realize that there's an increase in peristaltic activity in your stomach. That's why you hear this growling sound, because the stomach is trying to ask you to actually signal to you to that, so that you can go and get some food. So in this part of the video, we actually learn about the main concept of how the mouth, esophagus, and stomach play a role in digestion. So just to wrap it up, in the mouth, you actually have what I call the salivary amylase. Okay, salivary amylase is an enzyme that helps in the digestion of starch. Okay, so this actually helps to digest starch. And you know what you get after digestion. And in the stomach, you have this enzyme called pepsin. Now pepsin is slightly different. It's supposed to digest protein. Okay, and it digests protein to form something as well. Okay, so that's just some general things that we cover in this particular video. Of course, take note that this has an optimum pH of 7, and this operates at an optimum pH condition of about maybe 3 or so, as well as acidic. And with that, we have come to the end of this video, and stay tuned for the next particular video. Thanks.